And you walk out this long gangway and into the little white suit-up room. It's like a tent against the space shuttle, and the guys put a harness on you. It's the harness that connects you to your parachute, just in case you had to jump out of the space shuttle during launch. And once they get everything squared away, then at the end of that white room, there's a round hole in the wall. And that's the entrance to your spaceship. And you get on your hands and knees and you crawl into your spaceship like you're climbing into somebody's tree fort or something. And what's weird about it is the space shuttle, of course, was designed to land as an airplane. So it has wheels on the bottom. So it's designed in sort of the same orientation as any airplane. But for launch, it's sitting like that. So imagine if you went out to your car someday and it was sitting in the parking lot like that. Everything's all messed up inside. You have to open the back door and climb in and stand on the back window and then crawl your way up into the seat. And for most of the people, that's not a big deal. But for the person who's driving, you don't want to bump the gear shift and stuff while you're wearing this big suit. In the space shuttle, it's magnified because there are about 500 switches in the cockpit. And if you bump a switch, you die. So you don't want to bump any of the switches. So you get yourself wormed up into your seat, and then there's one other astronaut in there who's not going to space with you, who's just wearing a set of white coveralls, who goes around and fixes any switches that you bumped, and then gets your harness done up super tight because the forces that are about to happen are pretty incredible. Make sure all your checklists are right, and then once everybody's all squared away, that person crawls out through the hatch, and they close it and latch it, and you're alone in the cockpit after 26 years of getting ready, and the clock's ticking down. And there's a lot of things can go wrong during launch. Almost a countless number of things. And we don't ride rocket ships, we fly rocket ships. We're immensely involved with safely getting that thing to orbit. And no matter what fails, we have plans and backup plans. If we lose one APU and one engine and one of the main general purpose computers, can we still get there? Or do we have to abort and land in Bermuda or Newfoundland or south of France or somewhere? And you're so intrinsically involved. So laying on your back with your belly button pointed at the sky, that's what you're thinking about, is the thousands of things that you have to immediately recognize and be ready to respond to. Stuff you've been training for years. We understood the shuttle better than any vehicle I've ever flown, and I've flown about 100 different types of airplanes. And the clock ticks down, and 5 minutes before launch, the astronaut in the front right seat, who's the pilot, reaches over and throws 3 big heavy switches, over center switches, so if you kicked them they wouldn't go anywhere, so you pull them out and pop them up, 3 switches. And that fires up 3 little engines in the back we call auxiliary power units, and all they do is generate hydraulic pressure. But the beauty of that is now you have this hydraulic fluid that is suddenly pumped powerfully down into all the tubes of the shuttle, and it's like blood in the veins of the shuttle. It's like the shuttle it actually pulses underneath you. It comes alive, like in Young Frankenstein, life, and the vehicle's alive underneath you. And at 3.5 minutes before launch, we do one last check that everything's working right, and we swing the big rudder on the back, and then the big elevons, they're gigantic, and then the huge engines, they're like church bell-sized engines, and they all swing and move through their whole play to make sure that everything's communicating and functioning right. The reason you know that is because they're so heavy, the vehicle sways underneath you just with the mass moving around, and so it's like a beast coming alive, getting up off its belly, getting ready to lift you to space, like a dragon that's about to breathe fire. And 30 seconds before launch, the vehicle's ready to go. It's tested everything. By the time you hit 30 seconds, if no red flags have appeared, if everything's okay, we do a thing to clear all the memory out of the vehicle to get it ready to go. And then 15 seconds before launch, we fire the sparklers on the back. I don't know if you've ever seen that little clip of movie, but there's like a fireworks at the back, and that's just in case some hydrogen had leaked out. You don't want to light a fire with a little cloud of hydrogen there. It might go boom and knock a hole in one of your engines. So we fire these sparklers just to burn off the straight hydrogen. And then 6 seconds before launch, we have 5 engines on the back. 3 of them are on the shuttle, and 2 of them are on these 2 huge white rockets. Well, we light the 3 little ones that are on the shuttle. They're only 1.5 million pounds of thrust. But that's not, we weigh 4.5 million pounds sitting there, almost all of it explosive, all fuel. And we're sitting there, but we light those 3 engines because we want to make sure they're working. Because if they don't work right, then we would like to be able to shut them down and not commit to going. So 6 seconds before launch, our 3 liquid engines, they're burning hydrogen and oxygen, and they light on the back. And it's so much force. We're held by those 2 huge white rockets, but on these ones are on the shuttle, they're off center. So it's like someone took a huge pry bar and pushed on your vehicle from offside, and the whole vehicle bends, just all the metal bends right to the limit of its elastic limit, like a big spring. The whole thing, you're sitting there and you feel it sway forward. And NASA, in their terminology, calls it the twang. I mean, they call it the twang. Anyway, you twang all the way forward, and it takes about 3 seconds until it sort of hits the maximum metal limit of everything, and then it springs back, even though you still have 1.5 million pounds of thrust out. And the vehicle bends back to vertical, and that takes 6 seconds. But we knew it would. And so at T0, then the 2 huge rockets up the side light, and you go from 1.5 million pounds of thrust to 7 million pounds of thrust, just like that. And it's like some semi-tractor trailer just crashed into the side of your ship. There's this enormous pulse of energy, and then suddenly all the explosive bolts fire, you're released from the earth, and you're away. And it is like someone just stuck their foot in the small of your back. It is pushing you away from the world, a gigantic amount of power. It's 80 million horsepower. You know, if you buy one of the new Corvettes, I think it is 550 horsepower. We have 80 million horsepower at liftoff. It is raw, brute force. Burns fuel at 12 tons a second. Liftoff. It's just stupid. It is raw, ugly power. 100 years from now, we're going to look back and go, what were we thinking? But now it's the best we've ever come up with. And it is just pouring out the back. And if you look over to the left, and we all do because we train for it, you can watch the launch tower go zoom out the window. And by the time you clear the launch tower, you're going 100 miles an hour straight up. And you're just accelerating wildly. You go through the speed of sound straight up in 45 seconds, accelerating. Faster than Chuck Yeager went. And you do it in 45 seconds, straight up, accelerating. It's just crazy. And the force is so much, and the air's still thick. So you're just getting vibrated and shaken like super high frequency. When you get on Delta or something, it's kind of a big floppy thing that flies through the air. This is like a tuning fork you're riding, just shaking you so you can't even focus on the instruments. When you want to focus, you grab onto something and you pull your head against the acceleration because you're getting squished, and you let your neck soak up all the vibrations so you can see the instruments in front of you. And it's just getting harder and harder and harder, accelerating as heavy as it can until after 2 minutes, you're above the air. And those huge white solid rockets, like gigantic Roman candles on the side, they're suddenly out of fuel. And they've done their job. They got you above the air. That was their job. And they explode off. Big. And it's neat because you're above the air. If you stuck your hand out the window, you wouldn't feel a thing. Even though you're going 6 times the speed of sound, it's like a 2-mile-an-hour wind outside because there's just no air left. So when those things explode off, even though you're going 6 times the speed of sound, you get enveloped by the flame of those things coming off. And they fall down in the ocean and get used again. And now it's just you with the big orange gas tank and those 3 engines in the back. You're 165,000 feet up, going 6 times the speed of sound. But now you can really go fast because you're above the air. And for the next 6 minutes, it's just those engines in the back. Their job to get you like a dragster on ice, get you going fast enough to be able to stay in orbit. Because to stay in orbit, we have to go 5 miles a second. Any slower, we fall into the atmosphere. And so you're going sideways, going just faster and faster and faster, like just pinned in your chair. And as you're burning fuel, the force in your body gets heavier and heavier, until eventually the force is so high that it would actually rip the shuttle apart, rip the tank off the shuttle. And so once we hit up to 3G, we grab the throttles, or the computers do it, or we can do it manually, and you walk 1.5 million pounds of thrust. It's every fighter pilot's dream. You've got 1.5 million pounds of thrust in your hand, but you walk it back to idle just to keep the vehicle from ripping itself apart. And then for the last while, you're just watching Mach 22. Mach is the speed of sound, Mach 23, Mach 24, and you're trying to hit an exact speed. And it takes 8 minutes and 42 seconds. And at the end of it, you're high enough and you're fast enough and you're going exactly the right direction, and the tank's just about out of gas and the engine's shut off and you're weightless. That's launch.